welcome back to part B of Algebra Essentials. We will continue what we're doing, and essentially we just randomly looking at various questions in algebra, from substitution, solving equations, simplifying algebraic expressions, simplifying algebraic fractions, inequalities, among other hosts of topics. Alright? So this is part B, and I hope you find this very interesting. Alright, so let's start. Alright, so for this question, it's really about converting word phrases into algebraic expressions. It says change the following statements into algebraic expressions: 4 times the sum of x and 5. Alright? Now it's very tempting to write something like this: 4 times x plus 5. Alright? Now if you read straight, you might interpret this to be the answer. Alright? But it didn't say 4 times x plus 5. It says a sum of x and 5. Alright? So how do we write the sum of x and 5? The sum of x and 5 is just x plus 5. And 4 times the sum of x and 5. We put the 4 inside the bracket. So this will be correct. Alright? So this one is incorrect. Alright, let's look at part 2. It says 16 larger than the product of A and B. Alright, so if you're thinking about writing this 16 greater than or equal to A times B, alright, that's wrong. Alright, for some strange reasons, some persons associate larger with this symbol here, this inequality symbol, which means greater than. Alright? So larger doesn't mean greater than. Alright? Larger is actually plus. Alright? So the answer for this would be 16 plus the product of A times B. Alright, moving on. So this is a linear equation. So what we're going to do first is that we're going to use the distributive law and work out this bracket there on the right hand side. So we're going to rewrite the left hand side So 2 times 3x is 6x. 2 ones, 2. And we're going to group the x's. Now you can either group the x on the left or on the right. I'm trying to avoid negatives, so I'm going to group the x on the right. So what I'm going to do, I'm going to add positive 4x on the left. If I add plus 4x on the left, I will get rid of 4x on the left, and it will automatically come on the right. So I'm going to say 15, subtract 4x plus 4x. Alright, so I want you guys to understand the rationale why I'm adding plus 4x on the left. It's because I'm trying to avoid negatives. So nothing is wrong if you group the x on the left. Alright, so I'm going to write about the plus 2. So what do you know? This will give us 0. So what remains will be 15 equals 10x. plus 2. So we're going to get rid of plus 2 on the right by subtracting 2 from it. And what to do on the right, we also have to do on the left. So that will give us 0. And 2 from 15 is 13. So therefore, 10x is equal to 13. So x is actually 13 over 10. Or you could say 1 and 1/3, or you could say 1.3. Any answer will work. Alright, so I want you guys to check out this little gift. Wonder if that's me there. Alright, I guess sometimes it happens. Alright, so we're gonna look at this question here. It's an algebraic fraction expression. Alright, so what we're gonna do is that we're gonna draw our line and we're gonna find the LCM. Oops. LCM there is 15. And once the 3 into 15 goes 5, and 5 times the numerator. But what I'm gonna do, I'm gonna put that down here, because you don't want to make any mistakes. What some people do, when it's a 3 into 15 goes 5, what they do, they multiply 5 times everything there. So, alright? But you have to be very careful, especially if you have a negative sign. Alright? Alright, so 5 and 15 goes 3, so it's 3 times everything here. What we're going to do next is that we're going to use the distributive property to simplify the numerator. Alright, so 5 times x is 5x. 5 times 3, that's 15. That's going to be negative 3x. And when you notice, this is the part that will catch some people. 2 negative here will give you a positive. So you have to look out for that. Put everything over 15. And now we're going to simplify. Now 3x from 5x is 2x. Alright, so I'm just gonna squeeze the answer up here. So we have 2x. We have negative 15 plus 6. That turns out to be negative 9. I will put everything over 15. So this is our answer. Alright guys, so what we have here is an equation, or an equation with inequality signs. So these are not much different from regular linear equations. But there are times when the signs have to change. And that's the only difference. Alright, let us work this out. All right, so what we need to do is that we need to group all the v's, and yet again, just by looking at this, I would want my v to be on the right and the numbers to be on the left. All right, so what I'm going to do, I'm going to try to get rid of this negative v by adding v to the left and also v to the right. So I'm going to have 5 subtract v plus v less than equal to 2v plus v subtract 1. Now minus v plus v will give us 0. So end up with 5 less than equal to v plus 2v, or 2v plus v will give us 3v subtract 1. Alright, so basically we need to get rid of this negative 1 here, so we're going to add 1 on the right and also 1 on the left. So we end up with 6 less than equal to 3v. Of course, this will give us 0. And then we just divide everything by 3. And 3's cancel here. 23 goes 1, 26 goes 2. So we end up with 2 less than equal to v, or v greater than equal to 2. Alright? So when we flip around with the signs, the symbol will change. Alright? Alright, so let's move on to our next question. Alright, so we're asked to simplify. Alright, so this is pretty simple. The first one is pretty simple. We're just going to use the distributive law to work out this section here. So we have 3m subtract 2m, and that's 2 times m. Alright, and negative and positive will give us a negative. 2 ones, 2. These are like terms. 2m from 3m will give us 1m, or simple m, and we'll write back the negative 2, and this will be our answer. And you know we can't work this out. This can't go further because those are 2 unlike terms. Alright, let's look at part 2. Now part 2, just to simplify, so this is an algebraic fraction, but it has a unique denominator. Alright, but before we proceed, let me just refresh your memory. What if we have something like this? 1 over a plus 1 over b. The LCM would be what? AB. Alright? Now suppose we have 1 over a and 1 over, say, BC. The LCM would be a BC. Alright? Let us say we have 1 over a plus 1 over b, say, plus 1. The LCM would be a times b plus 1. Alright? So having said that, let's try to answer this question. Alright? So let me just rewrite the whole thing on this right hand side here. There's some brains going on right here, so you know. I don't want to start a brain. So can you tell me what you think the LCM would be for this question here? Of course, you're correct. It's y subtract 2. Alright? And then no, normally we're going to say this y into this LCM here. That's true. Now y into all of this, what's going to happen is that the y is going to cancel out. All right, let me write it. So y into this actually means y subtract 2 all over y. So when I say y, this y into this LCM here, this is what's going on mathematically. All right. So these two y cancel out, leaving y minus 2. So y into y and y minus 2 will give you y subtract 2. And then we're going to say 3 times y subtract 2. But I'm going to put that right down here. What about the minus sign? And then now we're going to say, let me just erase it. Then we're going to say y subtract 2 into y times y minus 2. So essentially what we're saying is that y bracket y minus 2 divided by y minus 2. Alright? So when we say all of this into that, this is what's really happening mathematically. So as you can see, y minus 2 cancel y minus 2, left back what? Y. Alright, and then we're going to say 2 times y. So let me say it again. Y subtract 2 into this LCM here, the 2 y minus 2 and y minus 2 will cancel out, leave back y. And then we're going to say 2 times y, which is 2y. And we're going to use distributive law to work out this little bracket here. So 3 times y is 3y. 3 2s is 6. Let's worry about that. Negative 2y all over y subtract 2. Now, these are the only two like terms. So we're going to work it out. So we're going to get, so 2y from 3y is just 1y. So it's 1y subtract 6 all over y minus 2. So this is our answer. Sorry, little fellow. All right. By the way, this 1y and this y cannot cancel. Alright, so you leave it like that. Alright. Another equation. Now, there are many approaches to these questions, right? I guess I'm just going to go with my favorite approach. Alright, as you can see, Jimmy here really wants to do this question, not true? Right. So my approach, by the way, my approach to these questions doesn't mean that it's all gospel, right? You have different ways of doing this. Alright? You can cross multiply because it's an equation that contains a division. Alright? I mean, you could actually start off by removing the bracket first. Or what I'm going to do, well, let's try that. Let's remove the bracket. So 2 times x is 2x. 2 1s is 2, which is that's equal to 5 over 2. Alright? Okay, so we want x, right? So what I'm going to do, I don't need negative 2, so I'm going to add 2 to the left and 2 to the right. So we'll end up with 2x subtract 2 plus 2 equals 5 over 2. And we're going to have to add 2 to the right, not true? Yeah. So this will give us 0. So So end up with 2x equals 5 over 2 plus 2. Alright? Let's not get this mixed up. It's 5 over 2 plus 2. Alright, when you work that out, we get 9 over 2. Alright, let's go over here. So we have 2x equals 9 over 2. Alright, and I believe at this point we can cross multiply. So 2 times 2x will give us 4x. 1 times 9 will give us 9. And we divide everything by 4. So our answer there is 9 over 4. So x is equal to 9 over 4. Or you could say, you could reduce that to a mixed fraction, which is 2 and a quarter. Alright, so this is just one approach, alright? Actually, no, I actually worked on this question before and I didn't actually use that approach. You know, what I did was to just get rid of this 2 here at the denominator here by multiplying the whole thing by 2. Alright? Alright. Alright, so this is an application question and a worded question, equation question. Alright, so we have a drinking straw, right? So let's draw a little straw. Alright, that was pretty neat. So the drinking straw has a length of 21 centimeters. So total length of the straw is 21 centimeters. So the straw is cut into 3 pieces. The first piece, all right. So what I'm gonna section it, right? And these are just I'm just marking these, all right? All right, so the first piece is x centimeter. The second piece is 3 centimeters shorter. So that's x. Subtract 3. All right, has to be subtract. All right, and the third piece is twice as long as the first piece. The first piece is x. So the third piece is twice. So twice means 2. Alright, so question number 1. State in terms of x. Now, in terms of x means that your answer must have x in it. The length of each of the pieces. Well, we just did that. Alright? So we can write it down here. So answer for part 1. So we have x subtract 3, and we have 2x. That's part 1. Part 2, it says write an expression. Now, expression do not have an equal sign. Write an expression in terms of x. Here we go in terms of x again. To represent the what? The sum of the lengths of the 3 pieces of drinking straw. So, what thing they're asking us to do is to find the sum of those 3 expressions. Alright? So what we're going to do, I'm just going to, because I don't have enough space, let's call this part 2. So we're just going to add each expression. All right, so you can leave the answer like this, or you can simplify it. Let me just simplify it, because it didn't say in the simplest terms. So, well, x plus x will give us 2x, and true. So x plus x will give us 2x. 2x plus 2x will give us what? 4x. So it's actually 4x minus 3. So this would have been a simplified expression of the 3 pieces of straw in terms of x as an expression. Now part 3 says so hence. Alright, hence means use your previous 2 answers then to find out, to work out the value. Alright, so calculate the value of x. Now if 4x represents the total length of the straw and the actual length of the straw is 21, then basically 4x minus 3 will be equal to 21 centimeter, and we can find x. Alright, so I'm gonna yet again, I'm trying to save time. Well, not time, space actually. So this is part 3. So it's the expression in part 3 is 4x minus 3, and we want x. So we're going to put everything equal to the length of the straw, which is 21. Clearly we're going to add 3 to the left and 3 to the right. So we have 4x equals 21 plus 3, which is 24. So I skip a little step because of space. So then we'll just divide everything by 4. So x, ladies and gentlemen, is equal to 6. All right. Now we can actually find the length of each side. So x is 6, so we replace x with 6. This will be 3 subtract 6, which is 3. And 2 times 6 is actually 12. If you add everything, you get 21. So the third piece is actually the longest in terms of proportionality. All right, so that's the end of that question there. Let's move on. Okay, so this is a simplification question. So the LCM here is going to be n times 3n. Alright. So let's work it out now. N into this LCM here, the 2 n's will cancel out. So let me write it like this. N into n times 3n. What's going to happen? N going to cancel out with 3n. And then now you're going to have to say 3n times the numerator, which is what? 2m. Because that's what we normally do, right? We normally multiply whatever we divide into by the numerator. Alright? And then the other piece, 3n into n times 3n, which is actually like this. So this is what's really happening. So 3n into 3n will cancel out, leaving back n. And then we're going to multiply 5m times n. Alright, so let's simplify this thing here. So we have, well, let's simplify this. This is going to be 3n squared. Or you know what? Let me just leave it like that, because let me write back n and 3n. So I said, sir, what if you just a 3n squared? Not wrong. But I want to make it simple as possible. You know, some of you guys say, boy, sir, how we know how to do that? You know, how we know boy we're supposed to leave it like that and then multiply it? It takes practice and it takes experience. Alright? But if it's a 3n squared, it doesn't really matter still when you try to simplify it. Alright? So check this out now. 3n times 2m is 6mn. And this is gonna be just 5mn. Alright, so sorry about this. So I notice this is mn and this is mn. So those are what? Like terms. So 5mn from 6mn is going to leave us with 1mn all over n times 3n, which is the LCM. Alright? What's going to happen is that this n tends to load one of them n then. So end up with just 1m or just m over 3n. Or you know, you could say 1/3 mn. Doesn't really matter. So that's your answer. All right, let's move on. Okay, subject of the formula. All right, so what we can observe here is that we have a square root, and to get rid of a square root, we square. So that's what we're gonna do. All right, so we're gonna square on the left and also on the right. So I'm just going to use this question. So we're going to square that. So we'll square both of them. So what happens when we square the square root? The square root sign vanishes and the 2 also vanishes, leaving t plus r over g. But on the left hand side, there's no square root, so the p and the 2 takes the square. So we end up with t squared divided by 2 squared, which is 4, and that's equal to t plus r over g. Now the question says to make t the subject of the formula. It's an equation containing fractions, so we're going to cross multiply. And by tradition, it's always best to multiply the one that you want first. So because we want t, we're going to multiply 4. We're going to multiply that one first. All right, so it's going to be 4 times t plus r and this is going to be g times p squared. So we want t, right? So what I'm going to do, I'm going to use distributive law here. So let's go over to the right hand side of my screen. So 4 times t is 4t plus 4 times r, which is 4r, and everything is equal to g p squared. So we want t, so we don't need the plus 4, so we're going to subtract 4 on the left and also on the right. If we subtract 4 on the left, the 4 will disappear. Alright? And because of space constraints, I'm really sorry about this. I'm just gonna, so this is gonna vanish if I subtract 4r. So we have g t squared subtract 4r. So we want t, so we're going to divide everything by 4. This 4 cancel. So hence t is equal to g t squared minus 4r all over 4. And that's the answer. Alright, so to solve this, it's a equation with a division. So it says make p the subject. So we're going to cross multiply. And we're going to multiply the 1 with the variable that we want first. So 1 times p squared minus r. Well, 1 times anything will give us back the same thing. So that's p squared minus r. And then we're going to say q times t, which is qt. So we need to get rid of this minus r on the left. So we're going to add r on the left. And also we're going to have to add r on the right. So this will give us 0. All right. So end up with p squared equals qt plus r. All right. Now to get rid of a square, we're gonna square root. So we square root the left side and we square root the right side. So that will give us p. So p is equal to square root of qt plus r. Alright, let's move on to the next question. So here we have another worded equation. Alright, so the students in the class sell donuts to raise money for their school project. The donuts are sold in small and large boxes. The number of donuts in each type of box is given in detail below. Alright, so we have 2 types of box: small box, large box. And the number of donuts in each box is given as an algebraic expression. Now we have some more information. The students sold 8 small boxes and 5 large boxes in all. Alright? So question number 1 says write an expression. So an expression do have an equal sign in terms of x to represent the total number of donuts sold. All right, so 8 small boxes, and well, I mean, if a small box, if x represents the number of donuts in a small box and you sell 8, it's going to be just 8 multiplied by x, and that x represents the number of donuts that you sell in a box. All right, and for 5 large boxes, it's going to be 5 times 2x plus 3. All right. Okay, so we're going to simplify this. All right, so I'm going to ask you to simplify that. When you simplify, you're going to get 18x plus 15. All right. So 18x plus 15 represents the total number of donuts sold. All right, so that's the answer for part 1. Part 2 says the total number of donuts sold was 195, right? Calculate the number of donuts in a small box and also in a large box. All right, so now if this expression, you realize that this expression here is an algebraic expression of the total amount of donuts that was sold, but they give us the actual number that was actually sold. So we could say that these two are equal, not true? All right, and we're going to equate those and solve for x. So for part 2, we have 18x plus 15, and everything will equal to 195. So I'm going to ask you guys to solve this. So x, when you solve it, x will equal to 10. All right. So in a small box, remember a small box is x. So x is 10. So a small box is just 10. 10 donuts in our small box. A large box is represented by 2x plus 3, and that's 2 times 10 plus 3. So that's going to be 23. So 23 donuts in a large box. A lot of donuts. All right. Okay, moving on to the next slide. All right, another transposition question. All right. So express u. So we need to find u. All right. So we're looking for u. Well, not me, no, you. Not you as in you and the viewer, but you as in the letter u. Because I can't find you, you're already there. All right, so we're looking for you. So well, let me tell you, but honestly for me, there's so many approaches, all right, to this question here. But what I'm gonna do, I'm gonna take another approach. Now, if this 2 wasn't here, life would be really easy. Not true? Yeah. So, what we're gonna do, we're gonna multiply the whole thing by 2, because 2 times a half will give us 1. All right. So that's my strategy. Multiply the entire thing, the entire formula by 2. So the 2 and s will give us 2s. 2 times a half will give us 1. So what we're left with is just u plus v with the t outside. All right. So the 2 doesn't take the 2, you know. Sorry, the 2 doesn't take the t. It just takes the half. And what we're going to do, we're going to use the distributive property here. So we have 2s. All right. So let me go upstairs for this. So we have 2s. All right. That's s on a 25 is equal to ut. So I'm using distributive law here. U times t. Yes, sometimes the letters can be on the right. And v times t, which is vt. But we want u, so we need to get rid of vt by subtracting vt on the right and also on the left. If I do that, I get 2s subtract vt equals ut. Then now we just divide everything by t. because we want u. Well, so now we're in the room. So the t will cancel out. So therefore u is equal to 2s subtract dt over t. And that's our answer. All right, so okay, let's look at part A. So it says factorize. That's what we're gonna do. All right, so clearly it's not a difference of two squares. It's factorizing powers. All right. So whenever we're factorizing powers, so we're gonna work out a1. Whenever we are factorizing with powers, we use the lower power number. All right. So we have x cubed and x1. So x1 is the lower power number. We have 2 and 8, highest common factor, there is 2. So notice for the number, we look for the highest common factor. For the letter, we look for the lower power number. Alright? So 2x is going to be our factor. Now we're going to divide the factor in each term. So 2 cancel 2, x into x cubed will give us x squared. Alright? 2 into 8 will give us 4. And x will cancel x. Alright? If you examine this bracket here, we realize that this is actually a difference of two squares. So we're going to make a step further and factorize the bracket. So, you know, when you factorize x squared minus 4, you're going to get x minus 2 and x plus 2. And that's the answer for the first part. All right, let's look at the second part. And just by looking at that, that is clearly a quadratic. All right, so we have a is equal to 3, b is equal to negative 5, and c is equal to negative 2. And remember, we're going to multiply a times c. Now, a times c in this question is going to be 3 multiplied by negative 2, which is negative 6. So we want two numbers to multiply, which gives us negative 6. When we add it, it gives us negative 5. All right, it turns out that two numbers are negative 6 and positive 1. Because when you multiply those two numbers, you actually get negative 6. And when you add them, you get negative 5. So the two numbers are negative 6 and positive 1. All right, so what we're going to do is that we're going to take out the middle portion, which is this, and drop in the two values that we get. It's going to be 1x, and then we're about the minus 2. All right, so we're going to bracket each term. So we have 3 and 6, the highest common factor there is 3. We have x squared x, the lower power number is there is x. And 3x and 3x squared, the back x. X into x cancel, 3 into 6 goes 2. Well, 1 is a factor there, and that's x minus 2. Now x minus 2, there, those are common, so we're going to pull it out as a factor. What remains is going to be 3x plus 1. All right, let's look at another transposition question. They seem to be coming at us fast. All right, so just make C the subject of the formula. So yet again, this 5 is a problem. Come on, big problem. So to make life easy, what do you think we're going to do? Let's multiply the whole thing by 5. So 5 times f will give us 5f. 5 times 9 over 5, 9/5. What's going to happen? 5 and cancel, leave 9. There's actually 9c. And 5 times 32 is 180. All right. You might be saying that, sorry, in the previous question with the s and the u, all right, when we multiply the 2 and a half, only the 2 and a half work out. But in this case, when I multiply everything by 5, I work out the whole thing. It's because in the previous question there was a bracket. All right. So we want C. So I don't need 180 over here. So I'm going to subtract 180 on the right and also on the left. So we end up with 5f. Subtract 180 equals 9c. It's not 118, is, let me check it. 5 times 32. It's actually 160. All right. But you know, just testing you guys to see if you're actually paying attention. You know, that's my usual way of finding out if you're sleeping in my class. All right. So that was a test. All right. So no, I screwed up a while ago, right? So something interesting. Okay. So 5 times 32 is actually 160. Right, so we're also going to divide everything by 9. And this is our answer. C is equal to this. That's the answer for part 1. Now in part 2, basically, we're just going to replace f with 113. All right. So 5 times 113 is 565. So 565 subtract 160 divided by 9 turns out to be 45. All right, so C is equal to 45 for part 2. All right, so let's move on. Okay, so, wow, interesting question here. Whoops. So we're almost the end of this program here. You guys are really learning. All right. So what we have here is a little flow chart, and basically it's a basic input-output diagram. You input x, multiply by 3, and add 5, and the output is going to be y. So it's like a little formula, a little factory, you know, you input certain things and add certain ingredients and you end up with a product at y. Okay, so part 1, use information from the diagram to write a formula for y in terms of x. In other words, y must be equal to something. All right, so this is in terms of x. All right, so for part 1, well, y Well, you input x and multiply by 3, so I'm thinking 3x, and you add 5. And that's it. Part 2, if the number 4 is the input, meaning the input is x, what would the output be? So the output would have been y, and the input would have been 4. All right? So 3 4 is 12. 12 plus 5 will give us 17. That's the answer for the first part. Part 3. Well, it's the same equation, right? So y is equal to 3x plus 5. If the number 8 was output, what number was the input? So basically saying y is actually equal to 8. So we have 8 equals 3x plus 5. All right, so we're going to subtract 5 from both sides. So 5, we're going to have 8. Subtract 5 equals 3x. All right, now 5 from 8. What's 5 from 8? 5 from 8 is 3. So we have 3x equal 3. So therefore x is equal to 1. So when the output, which is y, is equal to 8, the input is 1. All right? I know this is what we call modeling. This is the basic idea of what mathematical modeling is all about. All right? And you know, this is how factories and industries and ideas are formulated. You know, certain algorithms for a certain AI, it all comes up with a flow chart, an idea. This is the basic thing. All right. All right. So part 4 says reverse the formula. So we're gonna ignore this thing here, see here, and it says reverse the formula written at I above to write x in terms of y. So you notice the first part says write a formula for y in terms of x. So when it says in terms of x, it means that the right hand side must have x in it. But when it says write x in terms of y, it means that on the right hand side, y must be in it. In other words, we want to make x the subject of the formula here, equation 1. All right, so we have the same equation, y equals 3x plus 5. So we want 5. So we'll subtract 5 on the right and also on the left. So y subtract 5 is equal to 3x. And then just divide everything by 3. So the 3 cancel. So x is equal to y minus 5 over 3. All right, guys. Okay, so this is a nice little question. So it says write an equation in x to represent each statement below. Do not solve them. So when 4 is added for a certain number, let's call it n, you can call it any letter you want. The result is the same as having the same number and adding 10 to it. That's the first part. The second part is squaring a number and subtracting 6 is the same result as doubling the number and adding 9. That's the answer. So we're not required to solve it. All right, guys. So our last question. I think it's our last question. Okay, yes, our last question. All right, so It says the side of a square is in x meters. The length of a rectangle is 5 meters more than the side of a square. And the width of the rectangle is 4 meters more than the side of the square. What kind of question is this? Right. So, basically, you know what? We have a square, right? And you know that in a square, all sides are equal. And what they're saying, that each side of the square is x meters in length. All right, so all sides are equal to x, basically. And then now we have a rectangle. Now the long piece is called the length. So the length of the rectangle is 5 meters more than the side of a square. So it's x plus 5. And this is the length of the rectangle, the longest side. And the width is what? 4 meters more than the side of a square. So x plus 4 represents the width of the rectangles. So if you want to, we can put this in brackets. All right. Now it says, write in terms of x an expression with an equal sign for the length and width of the rectangle. Okay, so we have done it already. It's x, so the length is x plus 5 and the width is x plus 4. It says the area of the rectangle is 47 centimeters square, more than the area of the square. Let me say it again. The area of the rectangle is 47 centimeters square more than the area of the square. All right, so we know that the area of the square. Well, first of all, what's the area of a square? All sides equal x and 2. How to find the area of a square? It's length times width. All right. So the length is x and the width is x. That means the area will be x times x, which is x squared. So the area of the rectangle is what? So of the square is x squared. All right. Let's write an expression for the area of the rectangle. All right, so this will take a little effort. Now, how to find the area of a rectangle? Same way you find the area of a square, length times width. And so we're gonna multiply these two expressions here. So we have x plus 5, and we have x plus 4. And we're going to expand that, right? So it's x times x plus 4. So we're doing algebraic expansion. So what I'm doing, I am multiplying x times this bracket, everything here is up. And ladies and gentlemen, you have another approach. You could look at this. And then now I'm going to say plus 5 times x plus 4. Yeah, man, the same x plus 4. And then what we're going to do, we're going to use distributive law. So x times x will give us x squared. X times 4 will give us 4x. 5 times x will give us 5x. 5 fours is how much? 20. And these are two like terms. So we're going to put them together. Work them all together. So the final thing is x squared plus 9x plus 20. All right, turns out to be a quadratic. All right, but this represents the area of the what? Of the rectangle. All right. So let's get back to this now. So they say that the area of the rectangle is 47 centimeters square more than the area of the square. All right. So I'm thinking, if this represents the area of the rectangle, all right, this must equal to x squared plus 47, because I'm saying the area of a rectangle is 47 centimeters square more than the area of a square. So x squared represents the area of a square, but it is 47 centimeters more. Or more means plus, doesn't mean times. They didn't say 47 times the area of the square. All right. So what I'm going to do, I'm going to equate x squared plus 9x plus 20 and put it equal to x squared plus 47. All right. So I'm going to erase everything. You guys can always, go back on the video. All right. So we have x squared plus 9x plus 20. And this represents the area of the rectangle. And that is equal to the area of the square, which is 47 times. All right, so this is also the area of the rectangle. All right, so what we're gonna bring everything over on the left hand side. All right, so we're gonna have x squared. So this x squared will go over. The 9x is already there. Well, there's no more x's. All right, and we can bring over the 20. So what you notice, x squared subtract x squared will give us 0. So 9x is equal to 20 subtract 47, which is 27. Divide everything by 9. X is equal to 3. All right, so x is actually equal to 3. So once you find the area of x, the question says determine the area of the rectangle. All right, so remember, we have this was our rectangle. We had x plus 5 for the length and x plus 4 for the width. Now x turns out to be what again? No, x turns out to be 3, right? All right, so guess what? So this is 3, right? So if this is 3, 3 plus 5 will give us 8. And if this is 3, 3 plus 4 will give us what? 7. So these are the actual numbers for each side. All right, and 8 times 7 will give us 56 centimeter square. Alright guys, so I believe this is the end of the workout Algebra Essentials video 2, part B. If you enjoyed it, hope you learned a lot. Alright. So I'll see you guys around, alright? Take it easy. Thanks for watching.